11.5 common logarithms. Common log is your calculator log. That's log base 10 of something. We'll say x. Log base 10. Calculator log. Okay, that's the button on your calculator, right beside, I believe it's number 7. Okay? On your graphing calculator. Scientific calculators should have them as well. So let's practice typing a problem in. So I just want to know, example, evaluate part A, the log of 5 times 2 cubed. What's that equal? Now, if you see no base, okay, that's your common log. So if there's no base, it's an understood 10. So common log, log with no base, that's your calculator. So let's type it in. Log of what? 5 times 2 to the third. I'm getting 1.602. Can you type it in? I'm having trouble getting that typed in. Pretty straightforward. Part B, log of 19 squared over 6. What's that equal? Again, common log. I'm getting 1.779 approximately. Any questions on how to type those in? Okay. There's been a couple of problems where we have had log of a certain base to a different number. The easiest way to evaluate that, or to type it in your calculator and look at it graphically, is to use what's called the change of base formula. Log base b of x can be rewritten as the log of x over the log of b. So we're taking a base b and we're rewriting it as a base 10, or a common log. Okay, looks like we have no base. Understood. Common log. We could actually write that with any base, okay, but for right now we're just going to do it as a common log. So let's take a look at an example. Find part A. Log base 3 of 7 equals x. Now normally, what we would have done in the past to solve this was we would use a definition of a log, and we would rewrite it as 3 to the x equals 7. Okay, here's a problem though. We would match up the numbers, but we can't match a 3 and a 7. I can't write them as something nice exponent, like 5 and 25, that I can match up. But 3 and 7 I can't. So how are we going to solve this? I'm going to use change of base. I'm going to take the log of 7 divided by the log of 3. And I'm just going to put that in the calculator. The logs do not cancel. It's not 7/3. Okay? .771. Again, that's the exponent that you would raise 3 to get 7. Again, we're using an approximation here. We're rounding it. So if I took 3 to the 1.771, it'd be really, really close to 7. The more decimal places we keep, the closer it's going to be. Okay? It's not accurate because we rounded it. Okay, so we can use change of base. The other option that we're perfectly allowed to do, it's the opposite of property number 4. Property number 4, we said log of base b of m equals log base b of n equals then m equals n, right? So I can solve this part if I rewrote this in exponential form by taking the log of both sides. I can take them away, I can put them back on too. That's just the opposite direction of property number 4. Do you follow me on that? Okay, where can I put that exponent? Out front because of property number 3. To get x by itself, I can divide. And isn't that exactly what we had over here using the change of base? So if you're given the log, immediately you can go to change of base. If you're given the exponential, you can rewrite it using the definition and then do change of base, or you can take log of both sides and eventually you will turn it into a change of base. Let's do another one. All right. Log base 9 of 1043 equals x. If you're given log form, the easiest way to approach that is just change of base. Log of 1043 divided by the log of 9. And we're going to put that into our calculator. And we get 3.163. In other words, if I rewrote this in exponential form, 9 to the x equals 1043. We were trying to find an exponent. On what? On 9 to get 1043. So 9 to the 3.163 should be close to 1043. It is. It's been rounded. If we were given this exponential to solve, you could just take the log of both sides. Put the exponent out front. And then divide. And get the same thing. Either way. Because I'm going to give you the third example the opposite way. I've given you 2 logs. Now I'm going to give you an exponential. And we'll work it out both ways. This will be the last one for today. Any questions so far? Last one. Still see some coffee. Take your time. Okay? All right. see. 6 to the 3x equals 81. Given that it is given in exponential form, I think the easiest way to approach it would probably just be to take the log of both sides. Property 3 says you put the exponent out front. Now we'll divide. So the log of 81 is going to be divided by 3 and the log of 6. Now you have to be careful when you type this in. Log of 81 is fine. But when you divide, you need to put the 3 inside of parentheses with the log, or you won't get the right answer. .818. So if I said 6 to the 3 times 0.818, I get about 81. It's close. It's rounded. What's the other option? Now, this is a little bit more difficult. Okay, we can rewrite this as a log. Immediately, I'm going to write the 3x on the other side because that's the exponent. That's what logs solve for. Now, what's the base? 6 of 81. Immediately, I go right to the change of base, and then I divide by 3, which gives me the same thing, right? Change of base. That's basically what we've covered today, common log.